I will see if I can get the projector turned on. Okay. And there's well, I know you're in here. Oh. Okay, well, there you are. All right. We are now recording. We even have projection. Let's get set up from the current slide. Let's go over a few announcements. Okay? And with these announcements, also included is a proposal. Okay? So let's do the announcements first. Normally on Tuesdays and Thursdays, or at least for the first half of the term, my office hours have been 11:15 to 1:15. Okay? Today, not. Okay? At least I think not. And in some senses, I hope not. Okay? Why can I not find you? Skylar, there you are. All right. The reason is today I'm taking my physical science class on a field trip, and this will go into the next announcement. I'll go on and make it now because it's pertinent. Today is Miss Lawson State's coronation day, and the big event is this evening at 7 o'clock, just next door, whichever direction it is, at the Bessemer Civic Center. That way I think it is, okay? And evidently there's festivities going on all day long. I don't know if any of you are involved with it at all, but the van is tied up all day moving people around. So I couldn't get the van for the field trip. So I'm having to get one car from the Birmingham campus and one car from this campus. So that makes for a little bit of an interesting situation. So I have to leave right when my 11:15 class ends, the one that ends at 11:15. I have to book it to the Birmingham campus to pick up that vehicle, get back to this campus, and hopefully Mr. Hollins will pick up the other vehicle because he's the one going to be driving it. So there goes part of my office hours. Probably, I only had 2 hours. It's probably going to take at least an hour and 15 minutes to make the trip over, get the vehicle, and come back. Okay? So I'm figuring I won't be back here probably before 12:30, and then I'll have 45 minutes of office hours rather than 2 hours, or approximately that. I may not even make it back at 12:30, or I may make it a little sooner. Okay? So that's the first adjustment to office hours. The second, I don't think is going to happen now. I thought it would yesterday, but then I got an email. We've got to be out of town this weekend. So normally my office hours on Friday are 8 to 12. Most of the time I'm there well past 12, but technically my office hours are till 12. But I was thinking we might have to leave early because there are events going on Friday, but I didn't know what time. Well, I found out now that we can miss the first couple and make the important one, and it's much later. So we don't have to leave, I don't think, knock on wood, before 12 o'clock. But I do have to leave right at 12, so I won't be there any past 12, Birmingham West Campus. Monday, a fairly normal day. Tuesday, there's several things happening. One, temporary, the other for the rest of the term. The temporary one, and I told you all this before, I have a doctor's appointment next Tuesday. It's at 10:40, which sounds like it wouldn't affect this class any, except I have to go for blood work at 9:40, which means I have to leave campus by 9 o'clock to get there, get parked, and get the blood work done an hour ahead. All right, morning, there's Cameron. All right. Now, so that means This class will only have to end at 9 o'clock on Tuesday morning. And here is my proposal. Don't think maybe you'll like it too much, but see if it'll fit. How about Tuesday, Thursday, and the following Tuesday, starting class? You see, we're going to miss 45 minutes of class from 9 until 9:45, right? So why don't we start 15 minutes early? We can do that, can't we? What's that? Let's try starting at 8:15. I'm recording everything, so if you can't be here, you can pick up the little bit you may have missed before you got here. But especially this crowd, y'all are all here pretty much fairly close to 8:15, many of you, okay? So let's try to do it next Tuesday, Thursday, and the following Tuesday. Try to be here at 8:15. I'm going to get started. If you miss something, like I said, you can pick it up on YouTube, okay? You won't be missing that much, and that way we will get the material covered, at least all we can. How does that sound? Is that acceptable? Because it's all going to be recorded. So let's try to do that Tuesday, Thursday, and the following Tuesday. And that way we'll get our 45 minutes covered, and we'll be back on track pretty close. All right, so that's the issue. And then my office hours, normally on Tuesday and Thursday, like I said, were 11:15 until 1:15, but not Tuesday because my appointment is at 10:40, and I don't think there's any way, just based on past experience, that I'll be out of there before 11 o'clock, and probably not even at 11, but giving him the greatest benefit of the doubt, it's going to be at least 20 minutes, and I think longer. So I won't be able to leave there until 11 o'clock. Well, then it's about 45 minutes to get my car out of the parking and stuff like this and get back here. So that's 11:45, not 11:15. So probably the earliest I'll be back on campus is 11:45, more likely 12 or later, okay. But here's the good news on that. This is the end of first mini-term. Now this goes into the next announcement, so I'll go on and cover that while I was here. We are right at midterm. Sometime over the weekend is midterm, right on the nose, okay? So that means are any of you in a first mini-term class? Okay. Have y'all done your student course evaluations? Okay. If you haven't, there was an email sent with a link, and you can do the evaluation, get to the evaluation right through that link. Cody is here. All right. If you can't find that email, then you can go to the Lawson State webpage, okay? And at the main Lawson State webpage across the top, there's a bunch of blue tabs. And then there's one big gold tab, and it says Quick Links. And if you click on Quick Links, then you'll see a huge menu, and you'll probably have to scroll down for a while to get it. But look for something, I'm pretty sure it's listed under Student Surveys. I think that's the title for it. So look for that, or anything that would indicate it might be a student course evaluation. Okay, now this is for first mini-term classes we're talking about. And when you find that, click on that, and all the instructions will be there. It's pretty easy to do. Please do the student course evaluations. That's some of the campus's very best means of getting feedback from you. We instructors, we get feedback from you every day about looking at you, seeing how you're responding, watching you sleep. No, I mean, nothing like that. But we can find out a lot. But a lot of things like the registrar's office and library and food services, that kind of stuff, they don't always know what you're thinking. We don't always know what you're thinking. So tell them what you think. Tell us what you think in those student course evaluations. Please do those, okay? Now, that's one thing about being midterm. The second thing is sometime next week, they will probably open what they call midterm progress reports. And that's when we, the instructors, report on students who are either have D's or F's at midterm. A's, B's, and C's we don't report, okay? but these or else we are required to report. And I think every one of you, maybe not everyone in the class, but every one of you, I think, has turned in the first quiz. Most of you have taken the first test. Some of you may not have finished that. So I do have scores from you, but some of the folks, and I'm talking to people not here mostly, I don't have any score for. Oh, and by the way, since we're on that subject, research papers. This, my biggest class. And I have one research paper in, okay? It's midterm, folks. 1 out of 35 or so students. That's not a very good percentage. So please get working on the research papers. That was the littlest advertisement. Okay, so back to this. So I do need to do something. So if you can, please work on those research papers. That'll be a grade for you. That might boost your grade. Yes. Okay, you can't do it after class?
I have a class.
Okay. Are you going to stay in here? Or?
Yeah.
Okay. It's a normal shoe, isn't it?
Yeah.
Oh, good deal. And while we're on the subject of tests, to my great embarrassment, I don't have them graded. You started it, or did you?
Yeah, I was
Okay. I must have thrown it away. Oh, there it is. I just barely got started grading these. Yesterday, I found out we have student learning outcomes, we have unit plans, we have all this stuff we do all the time. I found out yesterday they needed immediately program outcomes and mission statements. See, we're coming up to SACS, which is our accreditation, Southern Association of Colleges and Schools, coming up soon. So now they're in a flurry to get all this stuff to make it look really good, you know. So now we had to make up something of what our program. No, I didn't say that, did I? Okay, out loud and on recording. Never mind. Okay. So anyway, that ate a bunch of my afternoon yesterday when I had hoped to be grading. Don't have much time today, but I'll grade what I can. All right, let me get back. So midterm progress report. Here's the other thing about office hours on Tuesday, and this is the sort of permanent thing for the rest of the term. First mini term, I've had a physical science class that went 1:15 till 5:45. Second mini term, I offered the second physical science class. The issue is the automotive students, a lot of them take this course, it's required for them, and they are in a block schedule and they are in their classes from 1 to 3. So I can't start the second mini-term class until 3:15. Okay, so that gives me, good news, more office hours. So starting next week, my office hours on Tuesday, Thursday, except for Tuesday, is going to be 1:15 to 3:15. 4 hours of office hours Tuesday and Thursday. Good news there. The bad news is I'm here till 7:45 on Tuesdays and Thursdays. So, but that'll be in class. All right. And I think that's about it on announcements. You know about applying to graduate and, you know, the note takers they're looking for and tutors they're looking for. Any questions before we get to math? All right. I think I got everybody here who came in. So let's move to, it says sketch the graph of each quadratic function and compare it to the graph of y is equal to x squared. So that looks like a good place to start. We didn't do this one. That looks familiar. Did we even start on it last time? I don't think we did. Okay. Okay. Let me get my pen set up. Were there any questions? Yes. Okay, you can't do it after class? Okay. I have a feeling I won't have many people listening, will I? Okay, but I'll mark it on. Okay. Here's run. Okay. Any other questions? All right. Let's keep going. So, I think I got my pen found. Yep. So, let's draw our axes. Now, I'm cheating a little bit. I'm looking at the problems, and I see that I can draw the x-axis way down here. Anyone want to tell me why? Everything's going to be positive except 0. I mean, but nothing's going to be negative. Okay, so let's tick off a few points here. 1, 2, 3, 4, 5, 6. Negative 1, 2, 3, 4, 5, 6. Positive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, something like that. Okay, give me a few points for y is equal to x squared. 0, 0, okay. 1, 1. 2, 4. Wait, I'm slow. I may be old, but I'm slow. 4, 5, 6, 7, 8, 9. That's as high as we can go on the positive side. Say again. Give me another point. Negative 1. And what would that be? 1. Negative 2. 4. Negative 3. 9. Okay, so here is the graph of y is equal to x squared. Something like that. I don't draw graphs too well. Okay? Now, I need another color. Red? Okay. All right, we go with red. That will be our alpha of x. 1/3 x squared. You sure we didn't do this one last time? We did.
I think we started. Yeah, we started graph. I don't think we finished.
Oh, okay. Then y'all should be able to do this really quickly, right? What would be our first point? 0, 0. All right. Next. 1. What's the y value? 1/3. Next. 2 4/3, which is 1 1/3. Okay. Next. 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 Second. 3 3. Okay. Finally got it out of somebody. All right. Now, we don't have any more on the original one, but we can do a few more. 4 would be 16/3, which would be 5 1/3. So there's 3, 4, 5 1/3 would be somewhere about there. 5 would be 25/3, which is 8 1/3. 5, 6, 7, 8 1/3, something about there. And 6 would be 36/3, which would be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't have it on the graph. Okay, I need something on the left-hand side. Negative 1 1/3, negative 2 1 1/3, negative 3 3, negative 4 5 1/3, something like that. Negative, what was it, 5 8 1/3. Where's that one? Right about there. Okay, so this appears to be the graph now. What has happened to it? Okay, it's a vertical shrink, is what we call it, because our coefficient there, 1/3, remember this from last chapter? If the coefficient is less than 1, then it's of your y value, okay, then it's a vertical shrink. Well, we won't go into that. Now, I need another color for G. What would be a good color for G? Second? Blue? Light or dark? Light. Okay, Carolina blue, okay? Nope, didn't take. There we go. All right, what would be the first value? 0 0. Someone's good on that one, okay? Next. Again? 1, 2. Buckle my shoe, okay? Next. 2. Say again? Say again? Okay, 4 would be the original one, but now we're doubling that. 8. 2, 8. That's up here somewhere, I think. 2, 3, 4, 5, 6, 7, 8. So 2, 8 is right about there. And 3 would be off scale, 18. So how about on the negative side? 1, 2, negative 1, 2, and negative 2, 8. So you see this now, because you have a 2 greater than 1 multiplied by it, it's a vertical stretch. You've taken this and stretched it upward, so this is about how, I forgot to circle, the G function goes. Something like that, okay? So you see what's happening when you have these multiples. Something multiple. What if that would have been a minus 1/3? How would that have looked for the 8? It flips it over, and that would have been going downward. Your red would have been flipped over the x-axis, okay? See how it works? A number greater than 2, like 3 or 4, even more of a vertical stretch, okay? So that's how it works. Any questions? All right. I'll clear this graph. You'll get to see how not quite as pretty a graph looks, okay? And that would be, here is your f of x, your y is equal to x squared in gray, and then they drew the 1/3 x squared there, and you see it's a vertical shrink. Everything is shrunk. All the y values are shrunk by 1/3. First one was 1, 1, 1, it became 1, 1/3. Next was 2, 4, it became 2, 4/3. It was shrunk. Okay. Then on the B part, everything was stretched by 2. 0, 0 stayed 0, 0, because you double 0, you get 0. But 1, 1 became 1, 2. Negative 1, 1 became negative 1, 2. And 2, 4 became 2, 8. Don't even show it on this graph. Okay? Created a stretched vertically function. Does that make sense? All right. Now, in that example, note that the coefficient determines how wide the parabola opens. I like to say how much it stretched or shrunk. When the absolute value of A is small, meaning less than 1, the parabola opens wider than when the absolute value of A is larger. Okay? We know that the graphs of, okay, let's talk about these for a minute. Y is equal to F plus or minus C. What is that going to do? What kind of activity do you find from that? This is review from the last chapter. What does adding or subtracting something from C do? From X do?
Is it a vertical?
Second?
A vertical?
Okay, the X you're adding or subtracting from X. X is where? Horizontal. Okay, and what's that doing? A plus C would be going? Yeah, it's backwards, right? And a minus C would be going to the right. Okay, stand up, sit down, 5, 5, 5. Okay, what would happen if you did the F of X plus or minus C? Moving vertically, which way? A plus C would go up, a minus C would go down. Very good. What would the F of minus X do? Second? Which axis? The y-axis, because you're negating the x, where you would have been going here, now you go here, okay? And y is equal to minus f of x, flipping over because this is a y value, it was a plus, now it becomes a minus because you negate it. Okay, so your y's go down. Those are rigid transformations, okay, of the graph y is equal to f of x, okay? The others that we were just looking at were non-rigid. Those were stretches and shrinks. Okay? So let me get Ashley here. Okay. Now, For instance, in these figures below, notice how the graph of y is equal to x squared, same one we used before, can be transformed to produce other things. Just tell me, what would this be doing to this? Say again? Okay, it flips it over the y-axis, the x-axis. Is that all? And then it moves it up 1. So it's a reflection across the x-axis and a shift upward. These sound familiar, don't they? Okay? In fact, very familiar for those who took the test, right? You had some of these on the test. And here's Alexius. So I got to get around there to mark it. Okay. Okay, but I don't use that pen. All right. Finally turning into a good sized attendance today. Now remind me before we leave to make that your favorite announcement again for the people who came in a little later. Okay, what does G here do to your y is equal to x squared? Say again? Shifts it to the left 2 and down 3. So here's your original. It shifts it left 2, down 3, and there's the parabola again. Okay. So that's same stuff we did in chapter 1. Now we're just doing it with quadratic, with parabolas. And they're pretty easy to do and see. Notice the shape, the size, and everything else hasn't changed. It's just the orientation where it happens to reside on the graph. All right. I didn't mention there was a checkpoint. Please do those checkpoints as soon as you can after class. If you need help, audio-video solutions of those are found at larsonprecalculus.com. Absolutely free website, no codes required. Just go there and find it. And So now let's consider the standard form for a quadratic function. If you had to, off the top of your head, tell me what the standard form of a quadratic function would be, what would you first say? Let me get up back to black. What would you say standard form for a quadratic function would be? Second? Okay, yeah. Quadratic formula, standard form for the quadratic equation is ax squared plus bx plus c is equal to 0. Because that's what we use when we're doing quadratic formula, and every other thing. That's the standard form for a quadratic equation. That's not the same as the standard form for a quadratic function, though that's how you'll see them most of the time. Rather than having an equal 0 here, they'll say f of x is equal to that. That's not the standard form, and there's a reason for that. Let's have a flashback in your memory. They used to say the standard form for a linear equation was ax plus by is equal to c. You remember that? What was good or bad or indifferent about that? Was it easy to graph that? No. It tells you nothing. The A doesn't tell you anything. The B doesn't tell you anything. The C only tells you one thing. If that C is 0, then it has to go through the origin. Other than that, C doesn't tell you anything. So it's a fairly non-useful form. Okay? For quadratic functions, that's a fairly non-useful form. That first one there. Okay? The A tells you something. A little bit. B and C tell you almost nothing. C tells you a little bit, but not much. Okay? In that form. So, what was the more useful form for a linear equation? Anyone remember that? You all know it. Y is equal to mx plus b. Why was that more useful? Yes, your two variables your two constants mean something. The b is the y-intercept, and the m is the slope. From that, you can graph the function without knowing anything else. just the standard form. Ax plus by equals c is a very pretty form, but it tells you almost nothing, okay? This tells you everything you need to know the graph. So that's why we get away from that that's no longer our standard form, okay? So let's see what the standard form is. You gotta be kidding me. That's your standard form? Alpha of x is equal to a times x minus h squared plus k. I've never seen them like that. Okay? But why in the world would we use that? Now here's a little hint. Remember, I said the a in the other form told you something? That's the same a, folks. That's the same a. And it still tells you what it told you before. You may not know what it's telling you, but we'll get to that. That form is especially convenient for sketching the parabola because it identifies the vertex of the parabola. Now, what would be the vertex of the parabola? What would be the vertex? Make a guess. Again? What would be the vertex of the parabola? Again? Okay, it's both an x and a y. It's what? On our y is equal to x squared, that's exactly what it was. What it is that lowest point or the highest point. That's the vertex. Yeah, that's what the vertex is. See, that other form didn't tell you beans about the vertex. This one tells you exactly because your vertex is HK. HK. That's why we write it in this form. It's just like the y-intercept was before. That tells you exactly where the vertex is. Y-intercept told you where it crossed the y-axis, the linear equation. This tells you the vertex. Now, thing to note about the vertex, the h is always the opposite sign, the k is always exactly the same sign. So whatever your form is, whatever the sign is before the h, the vertex is going to be the opposite sign. The sign before the k, that will be the sign for k. Okay, remember everything dealing with x is backwards, pretty much. Okay. So, here is the quadratic function, standard form, alpha of x equal a. That's that same a we had before, times x minus h squared plus k. Now, here's the deal. For this to be a quadratic function, a cannot equal 0. But that was true before. Why? Why can a not be 0? Yeah, well, say that again.
It would be a constant line, wouldn't it?
Yeah, okay, yeah. If a was 0, then alpha of x equals k. That would be your function. Not a quadratic. A linear function and a constant function is that. So that's the constant form as long as a is not 0. H could be 0, k could be 0, both h and k could be 0. That puts you at the origin, but a cannot be 0. HK, A can be positive, negative, fraction, decimal, rational, irrational, any real numbers. A can't be 0. Okay. The graph is a parabola whose axis, now, what would be the axis of that parabola? Remember, we used to call it the axis of symmetry, now we just call it the axis. What would be the axis? Okay. Picture your parabola. Say it's a parabola like that. What do we call this point at the bottom? The vertex. So what would be the coordinates for that vertex?
It'd be the x.
It would be x equal h. Exactly. If it's like this, x equal h is the line of symmetry. Because parabolas are always symmetric. No matter whether they're up or down, always symmetric. And they go through the vertex, so x equal h. So here, to get the axis of symmetry, and you have it here, just put, instead of a minus, put equal. Okay? If this was a plus, put equal minus. Okay? But that's what you do. Okay? That is the vertex for x equal h. And the vertex is the point hk. When a is greater than 0, it's looking upward, and the parabola opens up. When a is less than 0, in other words negative, it's opening down. Very good. All right. Any questions on that? So you can tell so much from putting it in standard form. Okay? I hope that y'all are going through in your mind, ooh, how do we get it in standard form? We're going to get to that, okay? To graph a parabola, it's helpful to begin by writing the quadratic function in standard form. Now, I don't know if y'all remember back from your earlier life in math when you did something called completing a square. You did that when you were leading to the the quadratic formula, right? All right, you thought once you had that done, you were through with it. No way. You're going to be doing it periodically from now on. Whenever you need it, pull back up that technique, completing a square, okay? So we're going to do that in example 2. And that example, we'll notice that when completing the square, you add or subtract the square of half the coefficient of x within parentheses instead of adding or subtracting its value to each side of the equation. Blah, blah, blah. Let's actually do it and see what happens. Okay, it says, sketch the graph of this function. Identify the vertex in the axis of the parabola. Now you have 2 techniques. You can start plugging in points, and then when you finally get enough points so you figure out the shape, then you might be able to figure out the vertex in the axis of the parabola. That's a long way for you hard workers, or any of you a little lazy. All right, good, good, good. Let's go for the simpler way of doing it, okay? Now, remind me what the standard, okay, let's write it in standard form, by the way. Remind me what the standard form is going to look like. F of x is equal to a times x minus h squared plus k, right? All right. Now, what appears, okay, in this one that we have up there, what do we know? A is equal to 2. This is the same A, folks. So the first thing we're going to do is take this one, the f of x, I'm going to write it again. Usually I don't do this, but I will this time. 2x squared plus 8x blank plus 7. Why did I do a lousy, loud blank like that to get your attention? No. Okay. First thing we're going to do is factor out the a, but only of the first 2 terms. That's why I separated them. So that will become what? Help me. Get out of there. That will become what? Factor out the 2. The a. 2 times x squared plus 4x blank plus 7. Pretty obnoxious blank, isn't it? Okay. Now, that's the same thing as we had before, right? Just with a big old nasty blank in it, right? It's the same value. Now we want to complete the square. Now, does anyone remember how to complete the square of this? Anybody? Let's go back and do a little mind jog here, okay, to see if we can recall. How would a perfect square binomial look? Let's just call it x. You want plus or minus? I don't care. It's plus, okay. Give me a letter, any letter. Say again? K. Okay. Now, it's not going to be our same K as before, so let's use a different one so you won't get it confused. L. Okay, that looks like a 1, but I'll write it like this. Okay. Now, if that was squared, okay, how do we square that binomial? Say again? Yeah, FOIL it. So let's just write it as x plus L. We won't even write it as a square. X plus L. That is a square, right? Now you FOIL it. What does that give you? X squared plus LX plus another LX plus L squared. And then what do those 2 LX's add to? X squared plus 2LX plus L squared. Perfect. Okay. Now, that's what we're starting with right now. Okay? We're starting with x squared plus something x and with nothing there. Okay? So, our first step to figure out what this thing here is to take half of the b term. Right? And what's our b term? 4. And what's half of 4? 2. Okay. So, what we'll do is start this to be, and really, you probably shouldn't do this, but I find it the easiest way. 2 times, we're going to take the square root of the x, so that's going to be of x squared. That'll be x plus 2, because that's what the L was right there. That's what it's going to turn out being. I know it because of the form of it. Okay, now what's the next thing we do with that L? You take half of the 4 and you get 2. You can write it down. Then what do we do with that? Now that we know the 2? Square it. So that's what we're going to do there, is square the 2. Goodness, this is so much fun walking around everything. Okay, so that's going to square 2 and you get positive 4. Warning, we just changed the problem. We changed it completely. We added something to it. And that's not fair, is it? Okay. What did we add to that problem by putting a 4 in that blank? What did we add to the problem? The obvious answer is 4. Not quite so obvious. No, we added 2 times 4. Didn't we? Okay, shame on you. So we added 8 to the original problem. So what could we do to compensate for that? Subtract 8. And then we'll have the same value we had before, right? If you add 8, you better subtract 8. So let's do a minus 8. Now, if you don't believe me, go back and do it, work it all out, and you'll see you get the same thing we had originally. Okay? So, what do we have now? We've already said this thing here is x, get out of there. Okay, x plus 2 squared. And then what do we have on the outside of the parentheses? Plus 7 minus 8? Minus 1. And guess what we've got? Standard form. Don't we? A times x minus h squared plus k. Now my question for you, in fact their question for you, we haven't sketched it yet, but let's first identify the vertex. What is the vertex? Uh-oh. Already forgotten what the vertex was. What's the vertex? Second. That's the highest or lowest point of a parabola. I'll buy that. But why were we getting to this form anyway? So we could get them back in the room. Oh, okay. Good deal. Did you finish? Excellent. Okay. All right. Why were we getting the standard form? What does standard form tell you? Yeah, the HK, that is the vertex. So what's your H down here? Negative. Ah, perfect. I'm sorry, I didn't hear it if you said it earlier. So that's what we just found. Huh? Oh, well, we just did then. Got it? All right, good deal. Did you finish? Okay. All right, so what we have discovered is your vertex is, say it again, -2, -1. Okay? How about the axis of the parabola? I call it AOS, axis of symmetry. Okay? And what's that? That's a little equation, very little equation. Oh, you've forgotten that one already too, huh? Say again? That's it. X equal -2. Okay? There's your axis of symmetry. Once you know the vertex, HK, then just do X equal H. There's your H, X equals -2. That's your axis of symmetry. All right. Now we've got a graphic. The trouble is I've used up most of my space with scratchy writing here. I know we can erase this part over here because this was just scratch work. Remember, we were jogging our memory, so we can erase. Oh, that didn't erase, did it? Okay. All right. This isn't erasing well either. Okay. It's kind of slow. It must be Thursday. Okay. Now, can we graph it on top of this, or do I need to write this somewhere else? What you say? Second? Yeah, it'll be fairly big. Let's see. Let's set up our axis like this. Something like that. Okay? We'll do a tick, 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 tick. The clock's running out. Get out of there. We'll do a tick, 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 a tick, tick, a tick, 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 tick. Okay. What you reckon the easiest thing, best thing to plot? The vertex. And how do I plot the vertex? What is the vertex? -2, -1. How do I plot that? Help me. Left 2, down 1. There's the vertex right there. Okay? Maybe another thing to plot would be the axis of symmetry. And that would be, do you want that in a different color or leave it black? Leave it red. Okay, we'll leave it red. All right, the axis of symmetry will be that vertical line going right through the vertex, x equal h. Okay? Axis of symmetry, x equal -2. Now I'll go back to black. All right. Now, I'm going to show you how I like to do this. If you find a better way, something you prefer, by all means go for it. Okay? Now, I think I've confessed to you before that I am a little lazy. Okay? No, I'm really lazy. Okay? So, the next thing after doing all this, I'm going back to that first thing, because that tells me one piece of information that is real easy to use when you're plotting. Okay? And that is what happens when x equals 0. Anyone answer that question? And what is that constant? 7. And what is the alpha of x? Oh, if you don't know that, y. So when x equals 0, y is equal to 7. That was easy, wasn't it? That's the only useful piece of information that form gives me. And what do we call that point where x equals 0?
Intercept.
Yes, the intercept. What intercept? The what? The y-intercept. The y, I thought that's what you said. Okay, so we know the y-intercept is 0. Get out of there. Why is this doing this? Okay. Let me go back to black. Okay. So the y-intercept from up here, y-I-N-T, is, what did we say it was? Are y'all listening? 0, 7. Right? 1, 2, 3, 4, 5, 6, 7. There's a point on the graph. Okay? I wasn't supposed to do that, but it's so easy. Why not? All right. Here's what I do next. Ah, ha, 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 clever dude here. Okay? Because that is the axis of symmetry. If you go, you see this is 2 units to the right. Go 2 units to the left. That would put you here. And go up here and plot you another point right there. He just used his axis of symmetry. Good move. Okay? All right. You know, Cody just left and I didn't make that announcement again. You will? Okay. All right. Can't get your name, please. Trees, I thought so. Okay. Sorry. Okay, I know you're in here. there you are, hiding. Okay. Now. Okay. All right. Now, here's how I go. You don't have to do it this way. I find it easy to do. Okay? Okay. We start back with that H. The axis of symmetry H, the vertex H, okay? And that's at -2, okay? Now here's how I find the easiest way to plot. I want to go 1 unit to either the left or the right of -2. Where would that put me? Either one. 1 unit left or right of -2. -1. So let's go to -1. Now let's go to our standard form here. Put x equals -1. Okay? -1 plus 2 is 1. 1 squared is 2 times 1 is -1 is 1. Okay? We just found another point. -1, 1. Okay? Right there. Okay? Do I have another clever individual who can tell me another point I can plot right now without even thinking about it? The other one. And what do you mean by that? The one across the axis of symmetry, right there. Okay? Now, if I went another point, right or left, that would put me at 0. We've already done that. So we have enough information now to plot this parabola. Because I can't go any further, okay? So there it is. Come down here, go through the vertex. Make sure the vertex is smooth, rounded. Don't make it a point. Don't make a point of it, okay? And there's your parabola. What's that? I can't hear this. What did you say? They're always ugly. They're ugly? Oh, I thought you were talking about mine. I was going to be so hurt. Okay. All right. All right, there's your parabola. Now, what do you notice about it? It's a stretched parabola because it has an A that's greater than 1. 2, okay? So it's stretched, but everything else is perfectly parabolic, okay? Can't get much easier than that. Well, maybe a little bit, but I can't think of a way to do it any easier. That's how we did it. Let's see how they did it. Can I erase, or y'all need it a little bit longer? Let me know. You okay? All right. So let's erase that, and let's see what they do. Begin by writing the quadratic function in standard form. That's exactly what we did. Notice that the first step in completing the square is to factor out the coefficient of x squared. That was our A. That is not 1, okay? If it's 1, leave it in there, okay? Okay? So all they did was write down the original function, okay? Let's see what they do next. They factor out of the first two terms only, that 2, okay? That leaves us x squared plus 4x, and what did they forget? They're blank, okay? They should have left it blank. They usually don't, okay? Plus 7, okay? Now, I want to make this a perfect square trinomial, and that means completing the square. And how do we do that? What's the first step? Once you factored out the 2, now you do what? Half of that and square, okay? So that will give us x squared, okay? Now they do this a little differently, and you can do it fine if you want to. X squared plus 4x plus 4, and they put the minus 4 in there too, okay? I just assume not, and just say, I just added 8 to it, subtract 8 from it. What they do. Now, how do you get this? Half of this squared, okay?
So it doesn't matter if you put it in the parentheses or out?
Yeah, and then they'll take that minus 8 and put it on the outside. Okay? So if that makes more sense to you, do it that way. If the way I said or some other way makes more sense, do it, as long as it's right. After adding and subtracting 4 in the parentheses, you must now regroup the terms to form a perfect square trinomial. See, that's why putting a blank in there, you avoided this. So you take your minus 2 times 4 outside with the 7 and leave the plus 4 inside. Now, if that makes more sense to you, do it that way, okay? For me, it doesn't, but that's just me, okay? And that gives you this, which is exactly what we got, right? Except I put the minus 8 on the right-hand side. It doesn't matter, okay? And that gives you. Now, they just sort of magically say that's the perfect square of that. The easier way to do it, as soon as you take half of this, including the sign, by the way, when you take that, write that down here, okay? Don't wait to this step. Write it down, because that's always going to be this number here. 1/2 of your b is going to be that number, whatever that is, okay? And you put it in the square. And then the minus 8 plus 7 is going to be your k, okay? Now, you got it in standard form. From that form, you can see the graph of f is a parabola that opens upward. What tells you it opens upward? Yes, the a is positive, okay? The a is positive, okay? And it has a vertex at, what does that tell you the vertex is? The opposite of the x value, -2, same value of the y value, so -1. -2, -1. Now, what can you get from looking at that? You can just write it down. The axis of symmetry is x equal -2. Have to make it an equation. X equal -2. You got it. Done. Okay? And then this corresponds to a parabola. Okay, now this is how they do it. And it's perfectly fine too. They go back and draw this parabola, which is y is equal to 2x squared, which means you do all the calculations for that one. And then they take that and translate it. Every point here, move left 2 and down 1. Okay? And every one of the points you do that. And if you want to do it that way, it's perfectly fine. Okay? The way I find it's easier is start right here and do plus or minus 1 and then plot. And by the way, because it's so easy to do, I apply to the x-intercept. I mean the y-intercept. And then you can do it right across the axis of symmetry. Does that make sense? Okay? Any questions? There's a couple ways you can approach it. Whatever makes the most sense to you, as long as you do it right. Okay? Now, you could just take that original formula and just start plotting x's and y's. You know, go for it. Okay? That works too. In the figure, you can see that the axis of the parabola was that line, x equal -2. You don't have to wait till you draw it. As soon as you get that vertex, you know what the axis of symmetry is. X equal h. Okay? Any questions? Okay. Now, to find the x-intercepts of the graph, we knew how to get the y-intercepts. How did you find the x-intercepts? How would you find the x-intercepts of that? What are the x-intercepts? Come on, Nick Saban would not be happy. That's where the... Say again? Yeah, where it intersects the what? X-axis, right? And how do you find where it intersects the x-axis? What do we call that? What is true about any place that intersects the x-axis? What is always true about any place on the x-axis? Think of all the ordered pairs on the x-axis.
X is 0.
Say again?
X is 0.
Not x? Y is 0. You're neither up or down. Y is 0. And what's your y in this? Where's your y here? You see a y? You better get that right. Where's your y in that? What is it? Okay, right there. Yeah, okay. If you don't know the answer to what is y, f of x, there it is. That's your y. Okay? So we set y equals 0. Now guess what that is? What is this? No longer a quadratic function. It's a quadratic equation. And how do we solve those? 2 different ways. Oh, don't tell me you've forgotten this. Factor it and then solve the 2 linear equations. Or, If you can't factor it, now you use the quadratic formula. And y'all remember that, don't you? Oh yeah, okay, I can tell. So, let's do the quadratic formula. Factor if you can. If you does not factor, use the quadratic formula. Someone remind me what that is. X equals, remember, minus B plus or minus the square root of B squared minus 4AC. Perfect. Over 2A. Excellent, excellent, excellent. Okay? But what in the world is the ABC? It's as simple as 1, 2, no, that's okay. What is your ABC? Those are your coefficients, so your square terms, the linear term, and the constant term. There they are. Okay. Now, okay, we're going to come back to this concept in a little while, but maybe not today. Let's see, how are we doing on time? Oh, man. Okay, time just flies when you're having fun. Okay. All right, okay. Oh, I forgot to say, there is a checkpoint bottom of page 117 after example 2. Please do that as soon as you can. So let's do example 3. Let's see if it's on here. Does anyone need this a little longer? Yeah. I'll let you. Okay. Now y'all remember this quadratic formula. We're going to come back to it probably next time. Okay, if not next time, sometime next week. Okay? Everybody got it? Anyone still writing? Okay. Look at them. They skipped 3. They skipped 4. Let's go back and do 3 and 4. Okay? All right. Here's example 3. Sketch the graph of f of x is equal to minus x squared plus 6x minus 8. This one I won't put the blank yet. Okay? Identify the vertex and the x-intercepts. Okay? Find the vertex. Okay? And find the x-intercepts. Okay? We're going to do more than that, by the way. Because as soon as I find the vertex, what else am I going to ask for? Axis of symmetry. Okay? And probably before we even get that far, I'll ask for the y-intercept. So we're going to have lots of stuff already on our plate before we go. Now, where do you want to start? Where do you want to start?
I'll let you know it's going to be upside down.
Say again?
It's going to be upside down, right?
Okay. He's already identified that because the A is a negative, it's going to be opening downward rather than opening upward. So we know that about how it's going to look.
Oh, wait, is this the same thing that we just did?
Very similar.
Okay. Is there any way that you do the other way?
Which other way?
The one we talked about, like the plug in the vertex?
Okay, we got to get the vertex first.
I know, like, that's what you said. The both way?
Okay, yeah, but we got to get the vertex first. Yeah, huh? Okay. Well, I'll have you lead me, okay? I always ask, what do we do next? So y'all tell me. What do we do first? You tell me. Factor out the what? The -1. Perfect. You factor out the A. The A here is -1. So this will be negative. You don't have to put the 1. And what you factor it out of? The first 2 terms. And what will that give you? X squared minus 6x blank minus 8. Remember your blank. You don't have to, but I like to. Okay? Now, what do we do next? Take half of the b, and what is that? -3. Don't forget the sign. Now, as soon as you do that, I come on down here and say this is going to be x minus 3 squared. I know it is. As soon as I take half of that, it's going to be what goes in there. I shouldn't do that, but I do. Okay? And what you do with that minus 3? You what? Square it. And what does that give you? Negative 3 squared is? Say again? Plus 9. Okay? All right. What have you just done to the problem? It's not the same problem. Well, you sort of added 9, but you did that inside the parentheses. What do you have outside? Oh, a minus sign. So you have to, this you actually subtracted 9, so we have to add 9. You're absolutely right. Plus 9. Do you see why that's true? When you put a plus 9 in here, because they had the minus out here, that was subtracting 9, so you add 9 to get back to the same form. Is that what you were talking about? Do it my way rather than the book way? No. No. Okay. You don't like it this way.
You were talking about how the book is.
Yeah, you're talking about the later on.
Later on.
Yeah, when you start drawing the graph. Is that what you're talking about? Yes, that's what I thought you were. Okay. But this is, again, a deviation from the book. What's the rest of this one? We already know it's minus. That's the perfect square of x minus 3. And what goes after that? Plus 1. Now you can tell me something. Something that they asked for at the top. What is that? All right. The vertex is 3, 1. Okay? And the other thing that you can write down right now, the AOS, x equal 3. Perfect. Okay. Now, we could have done this a few minutes ago, or we could do it now. Doesn't matter when you do it. But I suggest one good thing to do is to find the... Okay, we're going to do that. That much easier is the y-intercept. And what's your y-intercept? Second? Okay? It's where what is equal to 0? This, you go back to that original one. This is the only thing I do with that. Okay? Y, x equals 0, so cover those up, and what's your y? Negative 8. You see that? Okay. So the y-intercept is 0, negative 8. 0, negative 8. It's really the easiest thing to do. You can do it right off the top if you want to, before you do any of the other. Okay? Now we need the x-intercepts, because they told us to. How do we get those? Oh, that was 10 minutes ago, a long time. Okay, what's that? Yeah, we already did that. Axis of symmetry equals x equals 3. Okay? We want the x-intercepts now. We just talked about it, but it was a long 3 minutes ago. So. Right. Yes, I know. How do we get it? If the x and y-intercept is where x equals 0. Oh! What's the x-intercept? Where y equals 0. And what's your y? F of x, okay? So set that equals 0. So here how we get your x-intercepts. You do minus x squared plus 6x, yak. Okay? Minus 8 is equal to 0. Just set y equals 0. Okay? It's a little bit harder than setting x equals 0, but still pretty straightforward. Now, is there anything you don't particularly like about that, the way it looks? I don't like the negative sign. So, yeah, let's multiply or divide everything on both sides of the equation by minus 1. So watch me do it. That makes that a plus. It makes this a minus. And it makes this a plus. And minus 0 is still 0. Okay? So that doesn't change. Now what can we do with that? Factor it. If it's factorable, factor it. And what is that factorable? If it is, It's going to be x times x, right? The only possible factorization for x squared. Where did you go, Miss Joe DiMaggio? Okay, here we go. Okay. Only possible factorization for x squared is x times x. Where do we look next? Sign of the last term is plus. That tells you these two signs have to be the same, and because the middle is negative, they both have to be negative. So we want two numbers that multiply to be 8 and add to be 6. 4 and 2, you got it. Okay, and what does that tell you? Either x minus 4 is equal to 0, or x minus 2 is equal to 0. Why? The only way you can multiply two numbers together to get 0 is the answer. One of them's got to be 0, right? No other way you can get 0 as a product unless one of the two multipliers is 0. What does this tell you? If x minus 4 is equal to 0, what's x? X equal 4. You could do that by adding 4 to both sides. Or, God, is that gracious? Okay. Or, second, x equal 2. Is that what you said? All right. You could go through all that if you want to. So here we have our vertex, our axis of symmetry, our two x-intercepts. They're going to be 4, 0, because y is equal to 0, right? Yeah, get out of there. Okay. 4, 0, or 2, 0. There's your two x-intercepts. From there, you can draw your graph really easily. Now, I don't know if I have room for it. Can I? Let me erase everything except that piece of information up there, okay? I know this is going to take a... Oh, it didn't do it. All right. Wow, that's hard to erase. Okay. I know. I hope y'all got all this. Okay. Goodness, this is slow. Okay. All right. Let's draw our thing. Now we know it's opening down, and we've got to be up at least 3, 1. So let's draw the x-axis here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So what do we plot first? It really doesn't matter. We got several points on the board. What you want to plot? Okay, you can. You don't have to. How do I plot that? Right 3, up 1. Just don't say yours. Okay. Now, what are some other points you see on there? There's a 4, 0. How do I do that? Right 4. Don't go up or down. And right 2. Don't go up or down. Hey, I think I can even draw in the axis of symmetry here. Right? And they're symmetric across there. What other point do you see? Oh, yuck. 0, minus 8. We don't have it on here. We only have minus 5. But it's down there. It's down there. So we could do one more. We've already gone plus or minus 1. Is this what you want to do it this way? Okay. We've already gone plus or minus 1 from the axis of symmetry, x equal 3. So let's go either minus 2 or plus 2. Which you want to do? Oh, why? Okay, we can. All right, it'll work. That'll be the point 1, 2, 3, 4, 5. So if you put a 5 in, oh, I erased my formula, my other form. If you did that, you would find it was, what was it, x minus 3, wasn't it? X minus 3 squared. And if you put a 5 in there, 5 minus 3 is 2, 2 squared is 4. Negate that, it's a minus 4, and add 1 to it, and what did you get? Negative 3. And there we have it. Negative 3 here, negative 3 there. There is our parabola. Opening downward, vertex, axis of symmetry, y-intercept, x-intercept, and if we drum it far enough down, you can start seeing the y-intercept with the corresponding thing on the other side. See how it works? Good deal, folks. Let me give you a few homework exercises. I've got to mark where we're going to start next time. We're going to start with example 4 next time, right? So let me erase this. Okay. All right. So, starting with example 4 next time, we will do homework exercises. I'd say do all 4 of 5 through 8. Only the odds will be in the back of the book and at calchat.com, but do all 4 if you can. Then do any of the, either 9 or 11 or both. They're both at CalcChat, 9's at CalcView. Do any of the odds 13 to 25, they're all at CalcChat. 17's at CalcView. Do any of the odds 27 to 33, they're all at CalcChat. Do 35, it's at CalcChat. Okay, and before anyone goes, let me say again our announcement. The class, before y'all got here, decided unanimously, sort of, that, okay, good, over. Okay, that we were going to start the next 3 classes, that's Tuesday and Thursday of next week, and Tuesday of the following week, 15 minutes early. We'll start at 8:15 rather than 8:30. But I'll record everything, so if you can't get here, you'll still be able to hear it all. Because I've got a doctor's appointment on Tuesday that we're going to miss 45 minutes of class. So that's how I want to make it up to you.
I have a class that, like I get out, at 8:30.
Oh, really?
Yeah, because that's why I come to UAB.
Oh, okay. Well, I'll be recording everything. Okay. Unless you want to do a Friday or something like that. Okay.
Can I get a test?
Yeah. Okay, you're going to work on it?
Yeah, really quick. I have a class at 10, so I'm going to hurry.
Okay. All right, take care. Good class. Okay. There you are.
Thank you.
All right. You need it, okay. Let's see, were you further up? No, you're further down, I think, in the alphabet, aren't you? Huh? No, you're early in the alphabet, right? There you are. Okay. Johnson. There's Jackson Johnson. There you are. Oh, you're right at the beginning. Oh no. Yours is in another stack. Because yours is the one I got graded. Okay. I'll just be a minute. Okay, I know you're in here. Oh no, that's right, I haven't put you back yet, so I know where you are. You're at the bottom of the stack. There you are. Okay, good deal. Finished?
I had one more problem, but that's okay.
Oh, you can? Don't you ever say I can't.
Well, I had one more problem, but you'll be at the other campus Friday in the morning.
Yeah.
Okay, I'll come out and I'll.
Okay, you want me to take this with me Friday? Okay, I'll probably do it anyway, yeah. Okay, and what is tree? Oh, okay. There you are. All right. Oh, you're turning. Oh, you're quit. You want to start the test? Okay. That's in this stack. There it is. You need graph paper? Okay. It's pretty thin graph paper, I mean light, because the copier was messed up. Y'all gonna stay in here and work? Yeah. Okay. I'm going to be in 255, so when you finish, come to work.
Where is that?
It's at the corner.
Right
It's the one we started in.
Okay.
Right. Okay. I don't think so.